Hello, testing. Okay, I think we can start first. Later we can discuss about assignment stuff. Any question from last lecture? Have you tried out all the examples that we left for you to do? You do it yourself? Do you have any problem? I think I need to get some response from you. If not, I'm not sure what happened to you. Okay, so either you do it or either you don't do it. So if you don't do it, please find time to do. Otherwise, you get left off pretty soon. So I put out the revision class schedule, right? When is it? Next week? Which day? Friday. Friday, right? Okay, so make sure you try and do all these tutorial question, revision question. Okay, so where do we test until? So I think basically we will finish this polar curve chapter. Okay, test until this polar curve stuff. Starting from partial derivative is not tested. And so today we will finish up the polar curve and then finding the area. I think that's the last question you have to do with your assignment also. Okay. So please do a revision question, a tutorial question up to polar curve chapter. And then, so for the revision class, right, I won't prepare anything for you already because I already put out the practice test question for you. Okay, so you try and do it, and then a tutorial question, and then action notes. Okay, so if you have anything confused again, then we can discuss again on that revision class. Does it make sense or not? Okay, so do it, don't understand, bring question, or any question that you think about when you do revision, just bring it up. Okay, so when you do the practice test question, a very good exercise is you prepare your cheat sheet first. Okay, make sure your cheat sheet is usable during the exam. Don't bring it in and then tell me the cheat sheet is useless. Okay, so make sure you're familiar with your own cheat sheet. Okay, so whenever you do revision, whenever you do question, okay, in particular the practice test question, make sure it's useful, okay, for this question. So anything that you are unsure, definition or calculation, you want to include it in your cheat sheet. Okay, does it make sense? Okay, so practice this question with your cheat sheet. Right. So cheat sheet is A4 double-sided, handwritten only, handwritten. Okay, you cannot type, cannot print. No sticky note. Okay, no sticky note. Got students do that before. Okay, so don't do that. You'll get confiscated later. Okay. Okay, so let's recall a bit what's about polar coordinate here. And then we'll continue to discuss some tangent line and some area that we can found using polar coordinate. Right, so let's start with these comparison between xy plane and let's call it a theta r plane. Okay, so that we follow the order of xy. Okay, so what's the significance about a polar coordinate? So basically, we have something inside our xy plane that we can't really write down as a function unless we break the geometry down. Okay, so there's something that we can't really write as a function. So, but what we can do is, if you transform this into a polar coordinate, okay, then this circle is really a function. Okay, we can write this circle. Let's say this is a unique circle here. So we can write this circle as a function of angle. Okay, radius in terms of angle here. So what we call this function is the constant function in angle. Okay. So when we change to polar coordinate, this circle here become a function. Okay, but x squared plus y squared is not a function. Okay, so this is the advantage to go to polar coordinate here. Okay, but how do we draw these curve? How do we draw this polar curve? Do you still remember? What is the technique we use to draw polar curve last time? What's the plane we use first? We draw it on the theta r plane first. Correct or not? So we draw it on the theta r plane first. So what's this r equals 1 here? This is really a straight line. Okay, so how do you go from a straight line to a circle here? Okay, so you really need to start somewhere. So let's say we start from here, okay, where it is 0 and radius 1. So what point correspond to in xy? So if r theta is, let's say theta r is 0, 1, what does the sy point correspond to? Let's ask, who's check you again? Okay, check you, okay. Right? Which point correspond to? Right, okay. Huh? 1 and 0? Did you say 1 and 0? What's the xy point correspond to? Okay, and then 1 and 0. How do you compute this? Mm-hmm. Well, what are r cos theta and r sin theta here? Oh, okay. So you mean x equals to r cos theta, right? And then y equals to r sin theta. Okay, so basically, what do you need to remember to go between these two is these two equations. Okay? Remember, this equation comes from the sphere. Okay, sphere of radius r. Remember that we replace every point inside xy using a point on the sphere. Sorry, not sphere, circle. Okay, circle center at 0. Okay, good, very good. So this point 0, 1 here will correspond to 1, 0 here. Okay, but as you go along, when you increase the angle, what happens? The radius stay the same. Okay, so when you increase the angle, the radius is the same. Okay, so if you go along this angle and plot out the same radius, what do you get? You get a circle. Because circle is a by definition, it is the same, the points with the same distance from the center, from the origin in this case. Okay, so when you increase in angle, you have the same radius here. Okay, does it make sense? Okay. Well, maybe you might ask, what happened to the other side of this point here? What happened? About Jingsen, what happened? What happened to the point on the negative side? Where's the negative angle? Negative theta means what? So theta is going clockwise or anti-clockwise? Huh? Anti-clockwise. So negative theta, what is the not anti-clockwise? Clockwise? Okay. So if you go clockwise, what happens? The radius still stay the same. Okay, so meaning you are plotting all the point starting from this positive axis and then doing clockwise direction. Okay, so basically you also get the whole circle as well. Okay, so meaning what? Meaning if you take this line here, you are actually wrapping this circle infinitely many times. Correct or not? Because if you get a 2 pi, you already wrap once, and then 4 pi, 6 pi, 8 pi, and then so on. Okay? Okay, so infinitely many times. Right. Okay, any questions so far? Okay, right. So let's make a remark here. So let's compare again these polar coordinate. So already in the example above, we'll see that in polar coordinate, really we identify theta and theta plus 2 pi together. Okay, if you wrap a full circle, it is the same. So let me ask you a question. Let me ask you a question. So to cover, okay, to cover the whole xy, right? So to cover a whole xy, how many portion of r theta plane you need? Okay, so just now I gave you an example. So we start with a unit circle here. How many portion of r theta you need to cover this circle here? What you need is just r equals to 1 from, let's say here is 1, from 0 to 2 pi. If you go a bit more than it, you will wrap this circle again. Correct? No? Okay, so the question now I gave you is, how many, so what portion of this r theta plane here is needed, okay, to fill in this xy plane using circle? Okay, so meaning, how do you get all the other circle with different radius? Try and think about it. I give you 1 minute. You can discuss with your friend. Okay, how much do you need on r theta? XY plane. Meaning how to get all these different radius in circle with different radius from 0 to infinity. How do you do it? How much of this r theta plane? Huh? Any idea? Know what am I asking or not? I don't know. So, well, first of all, I want to fill this xy plane using circle, correct or not? So, I told you how to get one of the circle with radius 1 using this constant function from r theta plane using the polar coordinate, right? So now I want to filling all the circle with different radius. So how to get all these circle with different radius here? Does it make sense? How? If you want to try. Let's say that ask a concrete question first. So when r equals to half, how to get this circle from r theta? Okay, correct, good. So you just take where r is half here, constant, right? Then you can draw the whole circle. So similarly, what do you mean by r? What is r? What is real number? What is real number here? What 0 to infinity? So here is a 2D plane here. So you need to tell me a region. What region you can take? Which I mean here is 2-dimensional. You just tell me 1-dimensional. So how am I going to look for the 1-dimensional? From where to where? So imagine if I want to fill all the smaller r, right? How do I take? I just take all the constant line below r equals to 1. Correct or not? Okay. How about larger r? How do you construct, let's say, okay, concrete question again. R equals to 2, for example. So what line you need to take? R equals to 2 line, correct or not? So meaning what? You take all these strip of region here. Does it make sense? Okay. And what? And you don't need to include this 2 pi point because 0 will cover it, right? And then at the bottom part, maybe you can just take this 0 point here. Okay, so what do you see here? So when we do this polar coordinate, what we need is we just need this infinite strip here, actually just to cover our 2D plane. Okay. Does it make sense? Okay, I just need one infinite strip here to cover this 2D plane here. Okay. So this is how nice a polar coordinate can be. Okay, that makes sense. So there's a projection between these two. Okay. Yeah.
You can take I equals to 1.
Mhm.
Then you can, instead of I equals to 1, you can take I equals to -1.
Wait, let me think. So if we fix a convention, okay, if we fix a convention that we only can use positive r here, then this should be the projection. Yeah, if we fix the convention. Yeah. Does it make sense? So because every point definitely have a representation of positive r, so we fix that convention. Okay. Yeah. If you want to include negative, then you need to do some identification. Yeah. The four kind of way we can write such that a point on the polar coordinate have, right? So we identify 4 ways of writing. So if we just fit the positive presentation for r, then this is a projection.
Change the domain of theta.
What do you mean? Mm-hmm.
I to 3 pi.
Sure. So this strip will move. This strip will move. So if you change the domain from pi to 3 pi, then this strip will move to pi to 3 pi.
That's the
What do you mean? Yeah.
And then even by two curve, they represent the whole.
What do you mean by two curves represent the whole?
0 to 2 pi
Mm-hmm.
have a curve.
Yeah.
Pi to 3 pi is another.
No. I mean, when you you need to fix one way to talk about these points here. So we just fix. So okay. So so we fix our let me think how to say here. So we fix our R, the interval. I mean, yeah, the domain interval R from 0 to, let's say, infinity, and then our theta is just going from 0 to at least, yeah. So when we want to go from xy plane to polar coordinate, we just fix the interval and the domain interval that you can pick this number from. So in case if you want to swap this theta, obviously you can, like what you said, do pi to 3 pi, because we have a four-way of writing a point, right, in terms of polar coordinate. Then it will be bijection to the stream going from 2 pi to 3 pi, for example. Okay. Okay. So the point I want to draw this out is because when you do polar coordinate, right, what you really need is just a string, infinite string is enough. Okay, you don't need to take the whole R. Okay. Yeah. So this is the idea behind um, polar coordinate. Okay. So where did we left last time? So let's pick up a bit. So well, we talked about dy dx, right? So we know that by chain rule, this is equals to dy d theta. Wait, let me think. Should we take this here? And then dx over d theta here. Okay. But if we know the polar coordinate, right, of this x and y, we can write it as a polar form. Okay, how to write this in a polar form here? We simply just use the change of coordinate where check you told us just now, right? So you differentiate. Okay, just do it. Differentiate y with respect to theta. So how to write y with respect to theta? We have r cos r sine theta here over you differentiate x with respect to. Okay. Then to do this, maybe we know that the r is depending on theta. Then you need to do the chain rule. No, sorry, product rule. Okay. So if you do the product rule, you get something like a somewhat complicated formula here. So if you differentiate this, you get negative. So let's put here. And then plus e over d theta. Wait, okay, so this one should be sine. Then the other side should be a negative cos theta. And then you differentiate theta times cos theta plus theta times sine. Is it correct? Did I differentiate something wrong? Differentiate sign, you should get positive cos or negative cos. Positive one. I think I solved these two. Is it okay or not? Differentiate cos and differentiate sign. Okay. Right. So so if you try the example I inside the lecture notes, there's some special thing happens. Okay, so let's look at this example here. So that's this question here. So if you can look at it now. So consider r equals to 1 plus. Wait, let me make it bigger a bit. Consider r equals to 1 plus sine theta. Okay, so what's this graph here? So make sure you know how to use the r theta plane to draw it. Okay, so you need to do it in your assignment, like what we discussed last time. And then you use the r theta plane. So what's this r theta plane again? So let me just quickly draw it. So sine theta shifted by 1. So something like this. Okay, make sure you know how to go from this theta r plane to this xy plane. Okay. Okay, make sure you draw this in your assignment. Okay, don't use a computer, check it, and then just draw it out. Maybe you will lose half of it, half the marks. You can use computer to check, okay, but make sure you write down the working so that I know how you go from here to there. Does that make sense? Yeah. Yeah. Okay. So, right. So what's the question here? So there's a question says that find part 2, find the points where the tangent line is horizontal or vertical. Okay, so last time we talked about these two types, right? So whenever we talk about these words, don't remember formula first. Draw picture first. Okay, so what does it mean by tangent line is horizontal? So you have a curve like this. Your tangent line is horizontal. And then how about vertical tangent line? Maybe you have curve looks like this, and then you have a vertical tangent line. Okay, how to characterize these horizontal line and vertical line here? What happened to horizontal line? You see that the y doesn't change. Okay, so the y doesn't change. So meaning what? You want dy d theta to be 0. Okay. How about vertical? If you look at vertical, what thing doesn't change? The x direction doesn't change. Okay, so you want dx d theta is equals to 2. Okay. Right. So, well, you see, you are given r here, you're given x, y here. So what to do? So you have to ask yourself a question: how to go from xy to r theta again? Question: how to go from xy to r theta again? This answer not on this blackboard one. How to go from xy to r theta? How to do change of coordinate from xy to polar? Hmm? Remember what should you say just now? What should you say just now? Hmm? Sorry, y equals to r sin theta, and then x is equal to r cos theta. Okay, good. But in this case here, if we want to just talk about our particular curve here, what can you see? You see that the r is depending on angle here. Okay, the r is depending on angle here. So on our curve, on our polar curve, how to describe the xy coordinate? My y is controlled by a r function. Okay, so also r equals to 1 plus sine theta. So my y is equals to what? 1 plus sine theta times sine theta. Okay. How about x? 1 plus sine theta times cos theta. Okay. So this means what? Your polar curve, the look like a King Kong S, this one, right? The cardio. Okay. All these xy point is controlled by angle only. Okay, just controlled by angle. Okay, controlled by this angle here. So you see, you already express your y and x in terms of theta, then you can do differentiation. Okay, so if you try and do differentiation and then solve for the equation, what you get is, let's skip the calculation first. I want to show you something weird first. So if you do this calculation, what you will get is, so let's do a blah 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 first. You can compute it if you like, but what we get here is, out of a bunch of points here, you see 2 points in common. So the calculation is not wrong, but there's 2 points in common. What does it mean? What happened at these 2 points? At this 2 points, dy d theta is 0, dx over dt theta is 0. What happened at this point? What's the dy dx at this point in that case? Huh? What happened? So let me write here. So if you go through the calculation, you'll find this common point here. How do you interpret it? What is 0 over 0? So your dy dx there is 0 over 0. What's 0 over 0? I don't know. Yi don't know. Okay, so there's something not defined here. Okay, so what we need to do? Actually, we can do limit. Okay, let's do limit here. This one, operation not defined. Okay, so if it's not defined, so what do? We check limit. So we don't want to straight away evaluate at that point, but we approach that point from the side. Okay, let's approach this point from where? On the negative side, for example. Okay, so let's compute this. So let's look at the limit of dy dx instead of evaluate at that point. Okay, let's look at what happened if you go close. So if you compute dy over d theta and dx over d theta, I guess what you will get is, so let's quickly write it down. What's this calculation here? You will get at the top cos theta times 1 plus 2 sine theta. I think you can quickly check this if you like. And the bottom you get 1 plus sine theta times 1 minus 2 sine theta here. Okay. Right. Right. You know how to compute this limit here? So this is a calculus 1 question. So how to do this? Is there a quick way to compute this? What is sine 3 pi over 2? Huh? What's sine 3 pi over 2? We'll go and check. What is sine 3 pi over 2? Any idea? William, do you have any idea? What's sine 3 pi over 2? Minus 1. Okay. Sine 3. Okay, good. How about cos 3 pi over 2? 0. Okay. So in total, what do we get here? You sure it's 0? What's, oh, wait, let me think. Oh, yeah, right. It's 0. So did we get something weird here? So this part will go to 0. Okay. And then this bottom part, minus 1, right? Also go to 0. Okay. So here got a L'Hopital case, right? Okay. But here should evaluate properly, right? So 1 plus minus 2 should be minus 1. Okay. And then here, 3, good. So there's one part we can evaluate first. but the other part we need to use L'Hopital rule. Okay, so if we're gonna use L'Hopital rule on these two items here, what do we get? At the top we should get minus sine theta. At the bottom, cos theta. So what's the limit of this again? Just now, Liang said that sine theta will go to minus 1. So you got 1 at the top. Here, go to 0. Okay, so meaning this one will diverge. Okay, so actually you get the limit, okay, of dy ds go to infinity when you close to 3 pi. Okay, any question? So it's not 0 over 0. So 0 over 0 is quite controversial. If the top is really 0 and then bottom is really big, not sure how to do it. Okay, never mind. Don't want to go into this issue. But it's not defined. Okay, this thing here. Okay. Yeah. Any question? Any question? So why I want to bring out these cases, maybe you calculate the case like both the numerator and denominator is 0, but you don't really evaluate at that point. Okay, don't do evaluation at that point. Instead, you check the limit approaching to that point. Yeah. So obviously you can do the same calculation from the right. Okay, for 3 pi plus. Okay, by symmetry, you should get infinity also. Does it make sense? Okay. Okay, so you might wonder why my curve got this kind of straight line appear. So if you look at this King Kong S here, right? So where's the vertical tangent? It's exactly at this point here. Yeah, I'm not to mention what part is it, but this part here. Okay, so you get a horizontal one, then 3 horizontal, and then 2 vertical. Actually, 3 of them. But this one is a bit weird, where you get dy dx, dy d theta, and dx d theta. Sorry? Corner? What do you mean by corner? Differentiable? I think so. Yeah. Not differentiable. Yeah. You mean, okay. You mean this point called corner. Okay. I mean, in mathematics, we call a kink. K-I-N-K. If it's not differentiable like that. K-I-N-K. Kink. Okay. Okay. So the whole idea why we ask you to find tangent line and then draw the curve is that we want to instill an idea to you. To draw a curve, right? You can try and figure out what are the tangent curve. And then you can try and recover the whole curve using just tangent line here. Okay. Can you imagine if you forgot about the blue line, try and figure out what curve can fit all these tangent lines. Then you should figure out this is the only one it fixes. Okay. Does that make sense? So this is a very very advanced idea, advanced concept, where we study curve or in general manifold, okay, using these tangent space or tangent line. Okay, tangent line is just R. When we go R2, R3, R4, it becomes spaces. So we call tangent space. Okay, in general, if your manifold is like one-dimensional, like this, like a line, then your tangent space is also one-dimensional. If your manifold is two-dimensional, for example, the surface here, then the tangent space is also two-dimensional. If it's three-dimensional, then the tangent space should be three-dimensional. So the dimension of space between the surface or the manifold you look at is the same as the dimension of your tangent space in general. Okay, do you know what does the tangent space do? You know why we create this tangent space? like you got a curve, right? And then you draw a tangent line. I think you have an expose of the idea of speed, arc length parameterization, speed like that. Okay. So actually, you should imagine you are an ant running on this curve. Okay. Then at the certain point, okay, that tangent line is telling you what's your instantaneous velocity there. Okay. So it represents the speed. Look, speed is without direction. Okay, velocity is with direction. Okay, so more precisely is velocity because you know the direction, not just the number. Okay. So yeah, so I meaning this tangent line represent any possible way you can run around that curve. Okay, either you go from right to left or left to right. But whenever you met that top point there, your dy dx should be I mean your dx sorry your dy dx should be what? Should be what's the dy dx for this horizontal line? Should be zero. Zero, right? Yeah. Okay, should be zero. Yeah, in this case. Okay, so you should be you go very fast and then your change of rate of change there should be zero. And then you go down again. Does it make sense? Okay. Right. Is it okay? Let's continue. I think in this hour we can finish up this chapter here. Well, next part is about area. Okay, how to find area of a polar curve here. So let's start with the area of a sector. Okay, whenever we do theory, right, we start from something that is easily derived. Okay, so what do we mean by something that is easily derived? For example, we should know how to compute the area of a sector here. Okay, so what's a sector? Sector is a portion of your circle. Okay, a portion of your circle starting from the origin. So how to get this area here? Let's say this is a part of some big round pizza here. Do you know how to get this area in this case? Can you derive on the spot? Let's say this is a portion of a big pizza. Okay, so here is a theta, but all together you have 2 pi, right? Okay, so I want to get the area of a smaller sector here. So, okay, well, start from the easy question first. What's the area of your circle? What's the formula? Pi r squared. The total is pi r squared. But you can see that when we cut out the section here, there's a proportional property here. What's the proportional property here? If 2 pi, for the whole 2 pi angle, you have pi r squared. So I'm asking for just pi. 应该要这样 set up 这个 equation. So we have, for example, 2 pi correspond to pi r squared. So I was asking for pi. Am I confusing you? Am I confusing you? So if 2 pi correspond to pi r squared, what is pi? How to find it? So what's this area? A should be equal to what? A. 怎么算呢？对，交叉乘。OK，为什么要交叉乘？ 为什么要交叉成 ？So basically, what do we do? We divide our area into every radian and then pick up whatever radian you need. Does it make sense? 合理吗？啊 Okay. And then this in total you get what? Half times r squared theta. 对吗 ？Okay. Hey, if you no answer, please try 不要静静静静的话，这整个数学系是静静的，不能做事情的数学系。如果有答案，你就要 try。OK，错不用紧这个课堂就是为了你错才有的，不然你自己读就好了。现在很多 MAT 哈佛都是自己上网读的 course，不用来上课。你做好certificate发给你有对，但是这一个课就是让你有互动，让你学习，让你犯错。OK，但是 make sense？出去没有给你错机会哦。哇，我跟我老板讲话不是我一点错，他就讲我不听你讲。哇老喂，哇那你三呢？不是下一个老板，另外一个。不要想彼得，彼得很好。OK，不会这样的，不会这样的。所以你要尽量做对，不要给人家抓住把柄。但是你就算这样做，人家还是尽量抓你把柄。所以你要小心。OK 吗？这样说，在我班上勇敢发言，OK，勇敢发言，不然以后等下你没有机会发言。Okay, right. So we got this area of a center here, half r squared theta. But like what we said last time, right? This class will play around with curve that's not regular. So maybe what? So let's draw it. So maybe you want to compute an area, for example, like the polar curve looks like. Let's see what the polar curve should look like. So you draw something cardioid or limestone, right? So let's say if you want to compute the area bounded by this polar curve, how should we bound this polar curve? Should I draw like this or not? The area bounded by this polar curve. How should we? What's the area bounded by this polar curve should be? Okay, so this is the question. So the question is, where's the polar axis? So the question is, where's the polar axis? So last time when we do xy coordinate, right? What we do was xy here, and then we have this curve here. So why is the area under the curve look like this? It is because our coordinate is taken like the rectangle. Okay, so we fill in all this vertical line under the curve. But in our case, in the polar case, where is the polar axis? The polar axis is coming out from the origin. So when we talk about area bounded by polar curve, means what? We need to fill in using this polar axis here. Okay, so meaning we need to fill in the circular way. Okay, in the circular way. So let's remove some of this. Okay. Here. So indeed we get this kind of picture. Okay, so this is different. So this is so let me drop down here. Here is area under a polar curve. And then on one side we have area under xy curve. Okay, so you need to be careful when we talk about polar area or we talk about xy area. The tool is the same curve, it's the same curve, but the area under the curve is different. Okay, this depends on what kind of axis we look at. Okay, all right. So so this curve here is wavy or squiggly. So how to do it? Okay, so what do? We also use the limit method here. So this A, so let's refer to this A here, the polar A. So this A should be the half of f, sorry. Okay, so the integral, so let me not write down how to derive, so let's write it down first. So from A to B, so where's the A and B here? So this is the angle starting from A and then ending at B, okay, of your polar curve here. So let's call this r equals to f theta square d theta. Okay, so what's the difference with the formula before? Let's write down the formula before. A equals to half r squared theta. So what you see here is we are integrate over theta here. Why? Because our r is depending on theta. And then why there's an integration sign here? Remember what I told you last time, how we define this integration sign? It is a limit of some sum. Okay, it's a limit of some sum here. So it's a limit of, let's say, what's the sum here? I equals to 0 to n of half time f I star. For example, like this. Okay. So you are taking a limit of some sum. So how to create this sum here? Any idea? How to create this sum here? How to create this sum here? So in Riemann sum, right, what do? You create partition. Okay, you create partition. So in this case here, where's the partition you can think about? Actually, I draw in this picture already. Where's the partition? Can you see some sort of partition of your polar curve in this picture? Got partition 吗？诶，知道什么叫 partition 吗？不知道 partition 的概念呢？很简单，什么？切蛋糕，就切蛋糕吧。为什么切蛋糕是一个 partition？比如说我把蛋糕切了过后，我给一份给恩慈，给一份给小。你觉得恩慈的蛋糕会在小朋手上，还是小朋的蛋糕会在恩慈手上？没有嘛，对不对？但是呢，他们都是这蛋糕的一部分。So between these partition elements, their intersection is empty. And then if you add up all the partition together, it is the whole cake. This is the two main property that define partition. Okay, the union has to be the whole cake, and then the intersection have to be empty between these. So have I cut out your area or not? Did I cut it out? 有没有切？看它这样，看这照片有没有切？有没有切？怎么切？ I use the moving polar axis here. Okay, so if you imagine if I can cut it more, can you approximate this regular line with a more standard circle? 可以想象吗？还是你不相信我？可以想象吗？当我能够切的更多，OK，当我能够切的更多，so let's remove a bit. Never mind. So if I can cut it more, okay, how to cut it more? Like this, okay? Can you see that this portion here will look more like a part of circle? 懂在讲吗？还精神重复一下我讲吗？重复就好啊，对，没有错，对，没有错，就跟下一个圆，跟下一个圆过后，我们就可以用刚才的 area of sector 来说。OK，但是你可以看切这样还不够圆，还要再切多一点，切到多少多呢 ？Sorry，你觉得像圆哈？要他觉得像圆，他觉得像圆的话，我们要切无限多，其实切到超过几乎就是 like 一个点吧，就是一个点吧。 这样子，切到 limit 成一个点为止。OK， 一个点肯定是某个 circle 的一部分了嘛，对不对？因为它就是一个 radius。Okay, so this is what this limit is doing. Okay, this limit is like almost slice everything into a line. Okay, Riemann integral 也是这样。Okay，那个 rectangle 越来越小，越来越小，越来越小，越来越小，小到几乎就是一条线了。所以你是把每一条线加在一起。OK，一条线是最准的，把一条线肯定没有肯定没有 width， 肯定没有那个宽度。但是somehow这宽低又可以算出 non-zero 的东西，就是这个 limit 3的神奇的地方，或者这个 integral 神奇的地方。虽然它的 idea 是说我把它拆成一条线一条线，把线全部加在一起，但是你想想看线本身是没有宽度的，所以肯定没有 area 的。somehow 这个 limit 又算出一些有用的号码出来，又不是零。对，这是 integral 神奇的原因。OK 的。So exactly 我们不是把线加起来，但是我们还是看里面。idea 跟之前一样，我们不是 evaluate 在每一个点上面，但是我是去看它从旁边进去，它是什么情况。Does that make sense? Okay. Okay. Right. So let's compute one example and then we will take a break. Yes, so let's compute one example. Yeah, let's compute one example here. Right, let's compute this example. So try and compute. Try and compute the area of the region inside the limit zone. Okay, so what limit zone is this? A very simple limit zone here, r equals to 2 plus cos theta. Okay, so I can quickly draw you this graph here. So it's a bit pungent. Okay. Okay, let's just compute this only. So if you want to compute everything inside, what do? You need to decide your integration domain first. So, well, let's put out the formula from E of your theta square. Okay, so very one important 很重要的一个 point 这个一定要 square 这个是一个重点square r square. So how to remember this r square? Remember how we get the area of sector? That r square pops up from the area of circle. So area of circle need r square. So in general, you also need r square. Okay, so 不要少算这个 square in your solution. Right. So now you need to decide AB. How to decide this AB here? decide? How to decide? You need to look at where your curve start and where your curve ends. So where do your curve start and ends? 来，小笨。Sorry, 0 to 2 pi. Okay, so you really need to check whether it start from 0 and end at 2 pi or not. Okay, because sometimes your curve will end earlier or end later, depend on your parameterization. Okay, so you need to be careful here. So let me make a warning here. So a warning, when you do, especially when you do exercises in the textbook, okay, check where your curve start and end. Okay, sometimes they start earlier, sometimes they end earlier. What did I say? Sometimes they end earlier, sometimes they end later. Okay. Okay, so in this case here, you need the whole 0 to 2 pi, but it's just to integrate 2 plus cos theta square d theta. Okay, so if you go through this calculation here, you get 9 over 2. Okay, so right, so actually there are few ways to compute this curve. There are few ways to compute this curve. Last time I told you how many ways to compute dy dx. 3 ways, right? One way is to use xy coordinate. Second way is to use parametric equation. And then third way is polar. So similarly, we have learned these 3 ways of area. You can try and challenge yourself. Can you write down an xy equation for this curve? Do you know how to do it? Last time we briefly discussed, right? So how about I do it for you quickly. So let's quickly work it out. Okay. Right. So how to get an xy representation for this? Similarly, you will use the change of polar coordinate here. Okay. And then what do you need? Maybe you still need these radius with xy relation. So my claim is use these 3, you can turn this polar coordinate into an xy form. So let's quickly do it. So r equals to 2 plus x over r, and then this will get that r squared equals to 2 times r plus x. So altogether here you will get x squared plus y squared equals to 2 times square root x squared plus y squared plus x. Okay, so you get this. So see if you can compute area using this xy form. And you also can write down a parametric equation. Let me see, what's the parametric equation here? Let me see. So what's the parametric equation here? You just simply sub your r into this xy condition here. So there are 3 ways. See if you can all compute to 9 over 2 pi or not. Okay. I will pull out solution. These solutions are done by my previous students. Okay, so they do it. Okay, and then you should compare which way is easier. Okay, you should compare which way is easier. Sometimes depend on the curve you have. Maybe xy is easier, or maybe parametric equation is easier, or maybe polar form is easier. So you should compare which one is easier to compute to this 9 over 2 pi. Okay. Okay, does it make sense? Does it make sense? Any question? So I'll pull out solution. Those solutions were done by my previous students. Okay, so so we already computed one way. So here is the polar one. Second way is to use this. Third way is to use the parametric equation where you sub the C. So this xy way is the usual one, the usual calculus one way, right? So you basically compute area under the curve using this. And then this parametric way is what we learned in this chapter. Okay. Okay, any question? Any question so far? And I think we will quickly pass through this arc length here. So also in this polar form, you can work out this arc length formula here. Last time we worked out the xy coordinate, right? So basically you just sub your x and y in terms of r and theta and then get this formula. Okay, so it's just a different way to compute this arc length. 长度, 线的长度. So basically, in this chapter, what we did, okay, what we did was we have a curve inside my space. So how many ways I can describe the curve inside my space? I can just use the usual calculus one way, but if you cannot use xy function to describe this curve, what can you use? You need to introduce a third parameter, maybe the time. They use time to control the coordinate. So this corresponds to what? Parametric equation. Okay. And if you turn this curve into a polar coordinate, sometimes you can describe it just using a polar curve. Okay, write it as a r function in terms of theta. Okay, so these are the three ways. And then for these three ways, I have told you how to compute dy dx. Okay, for the first way, dy dx is just the calculus one. For the second way, what's the dy dx? We need to invoke the chain rule. So dy over dx is equal to what? Dy over dt over dx over dt. And then you do change of coordinate to polar coordinate, then you will deduce another formula for dy over dx in terms of r and theta. Where remember we calculate using product rule. Remember product rule. Product rule. 忘记了. Let's scroll up a bit. This is what we started just now. This one, product rule. Okay, so we find. Let me remove this. Okay, so we find dy dx also can in terms of r and theta. Okay, because we got the product rule from the chain rule before. And then what else? Give me the curve, I can compute the length of the curve. This is what we call arc length. Okay. Remember how we compute the arc length? We use a bunch of ruler, right? And then we relate to dx over dt and dy over dt. That one is for parametric. And then because we know how to go from xy to r theta using polar coordinate, then we can turn this formula to polar coordinate, polar form as well. Okay, so we can compute length. We can compute the area. Okay, area under the curve. Okay, area under the curve. So there's something to take note here is area under the xy curve and area under the polar curve is different because the different axis that we use there. Okay, in xy axis it is rectangle. Okay, horizontal, vertical. But in polar, it is what? Radial. Okay, radial from the origin. Okay, so in the area of a polar curve, how should you imagine? You should imagine how you partition your cake or pizza. Okay. 有没有人切披萨切成四方形啊？有不是？不太会切就切四方形啊。Okay, but really you can partition through the origin, 对不对？从中间切回去，懂怎样分嘛？会分嘛？如果你朋友生日啊，叫你切生日蛋糕，你会切？怎样切？怎样切到平均？啊，经验，你可以从中间切，对不对？中间切去它的中心点，然后再切一半这样，再切一半，然后再切一半，就一直一半再去，对不对 ？OK，does it make sense？ 他说你如果第一笔画错，没有切过它中间了，然后你就不平均哦。啊，哦，大的给你啊，小的给别人。OK， 什么？我有一个想法，什么？他的口音就画点了两字的。What? I mean， 他就不 ，I mean， 他就 ，I mean， 他语气一边了。Well， 哪里还有圆圈呢？来看一下，你看，如果画错，哪里还有圆圈哦？这样怎么办呢？第一刀画歪了，怎么办？等一下，这边表达。OK， 说第一笔啊，其实不重要，你知道吗？第一笔不重要，重要是中间在哪里。你只要从这一行切下去就对了。 它肯定是中间的。哎，相信吗？相信吗？I mean 你的线要够直啦，你不要切到像 zigzag 这样啊，对不对？你找到中心点，一笔画下去就是中间了。OK，and then 另一个中间呢要小心一点哦，另外一个中间你就要从这边看了。OK，然后这里中间你要画一笔直线下来就是中间，那就继续中间了。来的，this is what I meant。OK，but obviously 啦，你要看你场上有几个人啊，maybe 7个人要了解，还是多一个给一片别人，一个人多吃一片。I don't know, but it's your friend. OK OK 啊，Yeah，right。所以学好这一课啊，记得讲切西瓜，切蛋糕，切笔的。OK，any question？有问题吗？Okay, so try and do some exercises on your own. If you don't understand, then we can discuss again next revision. You want to get into a partial derivative this week? Okay, so if no question, let's break until 2:21.
你刚刚说那个作业要画那个
嗯，
R 西塔图是吗？
对，
是最后一题，
对，
在哪画呢？
从这电脑画，就画了，就步骤就摆出来，一步一步摆出来，怎么画到最后那个graph 就这样。哎，像我们班上画嘛，我们先画阿迪达嘛，画阿迪达再画那个 limison，对不对？嗯，
画
那这个啊，你反正最终也要画一个 sketch 那个 graph 嘛，对不对？
就是最后
然后
我们要画那两个图的。
对，那这个比如说 lecture 12，那个周五我们不是一起画的，那个周五，这样子，
这样是
呃，建讨，哎，建讨还不 decide your project one topic yet. Okay, I think we should decide this week. Because yeah, I'll make an announcement again. 小鹏呢？Have you decide your project one topic? Have you told me？跟我讲了吗你跟我讲了哈？你是什么啊？我忘记了。来读读看，哪一个？哎，你是做这个吗？我记得吗？等下我看一下，这我没有印象，有没有写在里面？你有看到我写在你们的 group 里面吗？没有哈，我是 miss 掉了哈。我就想没有印象耶。找之前，所以你要 prove both 啊？哦，OK，我让我 subscribe 了。OK，好。 tribute 谁用来的？零啊，美丽狗，零还是做 Taylor Series 对不对？要换，要换，等下再说。OK，玉后你的那个 Project One 定了吗？OK，啊，没有想到，应该这个星期应该要想出来了。OK，现在，嗯，春香呢？这三个礼拜不讲，OK，玉良狗一起没有在，海伦，诶，海伦跟我讲了吗？海伦，你定了吗？哦，你要做那个 Rose 啊，confirm 吗？OK，可以。Actually，那个有之前有人做过，你可以 try to refer 你要的。OK，意想呢？意想呢？sales 是什么东西啊？什么课？我没有印象，什么课啊？哦，可以可以啊。你要做 model b 诶，OK OK 好，OK，可以慢一点再问你。伟权，诶，伟权你 confirm 吗？Roman r e g i o n summation 啊？你做过 research 吗？他好像不太 rigorous，我不懂啊。不然你找不到得到好的 source 啊。但是我之前学生找的是不是很好？如果你找得到就 OK 啊。你要改，你跟我讲啊。Humble，诶，这周跟我说啊。OK，小英 confirm 了哦，小英不是小英 confirm。小杨呢？你 project one 要做吗？No confirm。OK，想一想啊。一平好像 confirm 了，对不对？一平 test。红杰呢？红杰 project one 还没想好啊，想一想啊。长云呢？还没想好，这周要大概想出来了，看看 lecture note 什么东西我让你们可以做的，然后选一个。有些 OK，有些我已经 list 在你们的那个 calculus two 的那个team chat 里面，可以看一下人家选了什么，就尽量不要再选那些。今年呢，project one 知道要做什么吗？做什么？要做什么？没有，不是 topic，只是说 project one 的 content 是什么，你需要做什么，你知道吗？你要选什么，你知道吗？So project one 是一个pure maths 的 project，OK，所以你要选一个题目来做，such that 我们班上没有 prove 过的，OK，或者我们班上有讨论那些理论啊，没有证明过啦，你可以拿去证明，OK，你要自己找资料，OK，这个是训练你自己读书的，明白吗？OK，说去哪里看？去我的 lecture note Moodle 下载下来读。我那边有说这个适合做 project one，这个适合做 project one，你就可以选。OK，选一个你自己喜欢的，OK 吗？然后我有放在那个 team chat，你知道我们的 calculus 二有一个群吗？我放在那里有说谁选了什么题目，就不要撞到。OK，因为有很多题目，明白吗？So in this week, by this week, I think all of you should get your topic ready already because after midterm, you need to submit project one. Correct, right? So you only left about 3 and 4 weeks like that. Okay, so you need to start now. Okay, so in this timing, you don't have actually assignment until we 11 something like that. Okay, there's an assignment 4. And then after assignment 4 is what? Project first or assignment 5 One of them come first. Project first, okay? So meaning after this project 1, you will do assignment 4 first. After assignment 4, you need to do project 2 or applied project. Okay, that project is relatively simpler. You just need to create one problem. Okay, real life problem 比如说怎样赚多钱 and then answer in that question is use calculus 2 knowledge to 赚多点钱 okay, so question is real life but answer is using calculus 2 knowledge. Okay, just about 1 page is enough because I want you to present, so you need to present that in 1 minute. So inside this 1 minute don't need to prepare 20, 30, 100 slides you won't be able to finish it. At most 经验 experience from my 2 class 6 slides is at most already. About 10 seconds 1 slide about 很快了，已经很快了，那个速度已经很快了。Okay, so in that presentation is like a seminar form. 哎，那天你们有几个人来啊？看到你们有人来，谁来？一翔有看到还有谁？1、2、3、4、5，还有呢？6，就这几个所以你们那天听懂了几什么？
天地有正气，
什么？天地有正气，很好，很好，很好，那个很重要，呀，那个很重要呀，那个很重要。那句话是差不多 summarize 了我整4年在做的东西。我都不是文天祥自己讲的那个意思啊。Yeah， 有那个 idea 在。OK， right. So in that presentation is a seminar form. So 你 present 给你的同学看 ，and then 同学问你问题，你问同学问题。OK。So 谁问问题就有加分。OK， 你回答得好，你也有分。So in that回答 when I want to see how you reply to people 其实 accuracy of 答案不是的最重要的东西 ，it's not the most important。因为我知道你肯定有些东西不懂的嘛，对不对？你肯定会讲错，我都会讲错，不要讲你会讲错，我上课我都会讲错。说对错这个不是很重要，重要是我要看你怎样去应对那个对错。Then this one will define your character。你老板就是要看这个，看你这个人合不合理 ，make 不 make sense， 错还是一定要错，还是你错了会改 ？OK。And then 如果是对的，你怎么去 explain 它 ，elaborate 它，让人家信服，相信你。我的意思是说 trust， 你要讲让人家相信。OK 吗 ？Does it make sense? So think about this. Think about this. It's very soon. Okay, it's very soon. Coming very soon. 现在差不多要过到一半了，我们的课，对，很快要结束。Alright, so 时间到了，我们会再讨论。But about Pure Max 全部人大概这个星期就要给我你们题目。Okay, all of you have to give me a topic, and then you start research. So in your project, right, you need to introduce any definition that you want to use. Okay, any that you need to prove your theorem or something like that. You need to introduce all of them in. Okay, does it make sense? 所以你是一个从头到尾完整的故事，你的paper，就是说我不用再去翻其他书了，读完你那一篇，我就是会明白了，我不用去找书了。Okay, this is the aim you need to write. Okay, 这是你的目标，要写成怎样 ？Self-content. 因为我不用去翻其他书了，在你的纸里面全部都有了，我要知道。OK， 不用写太多3 page the more， 不要写太多。你把第一个不要写废话，废话一定会被删掉 ，because you need to submit a draft first. Okay, so during the draft we will see. And then one very newbie problem 因为你们是新用 latex 嘛，你们不会排版嘛，对不对？那个 equation 会跑来跑去，就是有些人我不知道你们会不会吧，我有同学生之间所以去看一下 senior 的排版，看他们怎样排，什么时候 equation 要跑去中间，什么时候要排在一起。 and then 你看一下怎么，因为有时候啊，你会把 equation 跟文字啊贴在一起，很复杂整段东西，所以什么时候要把 equation 放去中间？你去读一下前面系列怎么排法，你会看到很舒服，因为是让他们变的，懂吗？啊，不然呢，我又要 go through 整个 process，所以你去看一下人家怎么做，OK？就算啊你的 topic 跟他一样啊，其实你也可以写出不一样的方式。OK，所以这是说 we gonna train，所以你不会有 plagiarism 这个问题啊，因为每个人的脑是不一样的，你的理解是不一样的，对于一件事情，所以很难 plagiarism。怎么会 plagiarism 呢？知道什么叫 plagiarism 吗？抄袭啊，什么情况下会抄袭？是当你不知道一个东西的时候，你去做，你就会开始抄袭啊。等你会了过后啊，肯定是用你的方式的。我就问你啦，比如说箭筒会不会抄小盆冲凉？会吗？会抄吗？大家都有一套冲凉的方式吗？但是冲凉是同一个每一个人都要做的事情吗？为什么不会一模一样呢？为什么不会一模一样？你有想过吗？你有想过这个问题吗？有想过这个问题吗？所以抄袭这件事情会产生啊，基本就是代表你是不会的，你不懂那个 knowledge，你试都没有试过，明白吗？你试都没有试过，你一点自己的理解都没有，你才会猜。OK，如果有自己一点理解啊，你肯定跟人家不一样，再一样都会有不一样的地方。但是抄真的很恐怖的哦，可以错同一样地方的。这是我们怎么抓抄袭？对，很难抓，很难抓的，对是很难抓，因为都对嘛，错就很容易抓。这样奇怪的错两个可以一起错，但是你不懂，你就不知道那个东西是错的了。我懂，我就知道这个东西是错的。所以是说你们可以讨论的，可以讨论，可以看朋友 check 一下答案，但是你就要知道咯，诶，诶，金色，你这样写对不对咩？对咩？那让你挖到它不对，人他也要改哦，一起改哦，明白吗？啊，你不会，你又抄了，一起错了，明白吗？OK，so make sure 啊，你们在沟通答案的时候啊要问对方，这步如果看不明白，为什么你这样写？你也可以顺便 check 他的，他有没有想错，真的。OK，或者写漏掉一些东西，没有解释到。OK，这些就是很重要的点哦，就是我会圈起来哦，哎，这么对啊，这么错或这么对啊，我就会圈起来哦。这些点你自己会问的问题，就是我会问的问题吧，一模一样的，一模一样的。OK，我是问一个正常人会问的。啊，我昨天跟我的另外一个班的学生开玩笑，也不是开玩笑啊，蛮认真的，就是说我是说数学啊是给天下最蠢的人学的啊，俊言。数学是给天下最蠢的人学的，为什么啊？你觉得为什么？你不知道，还是你觉得会？有听过这个观点吗？没有哈，你会觉得很奇葩吗？为什么？为什么是给天底下最蠢的人写？我们每一个 definition 都要写得清清楚楚，每个算法都要写得清清楚楚。为什么每一个 equation 要对？这不是给最笨的人学的，最笨的人看不懂，还有谁看得懂？你明白？为什么这么 rigorous？我们要让大家都懂啊。不懂的东西，我们自己都要挖出来。为什么不？为什么这边是对的？rigorous，我跟你讲啊，这个东西啊，在其他课是看不到的啊。比如说 AI，我有学生在 AIT 啊，你知道他老师的 slide 是怎么样吗？他就给一个 equation 跟一个图片吧，没有我们这样 define proof。你想一下，这样子你讲理解？1000人有1000个理解方式啊，但也读得下去哦，也毕得了业哦，不觉得很奇葩吗？对吗？OK，so that's why we make our math so rigorous because we need to explain to every person that don't know about this theory. Okay, we have to convince them.
他们不要学是另外一回事，一回事是要学的人怎么学的会，每一个不懂的点都要解释。Okay, yeah. So please take this principle in mind, and then this is how you should treat your assignment, assessment, or studies. OK， 剩下半个钟。哎，你们会觉得我一直讲废话吗？会，不要客气哦，不要客气，因为我这种废话我觉得很重要，不然我一直在那边讲你又不听，然后就很没有用。我虽然是讲了这种废话希望你听的时候会有不同的感觉，听课的时候，and then 当你做东西的时候也会有不同的感觉。OK 不然的话你一直带着你的旧习惯那种旧思维很难吸收这些knowledge， 很难吸收不了了，基本上是吸收不了。我有这种学生存在，第3年了，吸收不了。我有2批学生那边，一批是他跟着我做，或者他知道我要他做什么，他走出来了，觉得挺好的，可以帮助人的，就是在我 office hour 之间。也有一批人还是躲在家里的，到了第3年还是走不出来。我也不能够再讲他了我也不是他老师了，他人生是他的我管不了那么多了，真的。这样子的话，你一辈子也是这样子，可能你会变有一天记得谁跟我讲的那个我变了 ，maybe 以后但是现在我还没有看到。真的，如果你做老师可能你觉得怎样？中国语言摇头，什么叫摇头？你不做哇，真的是我也是这样想的，就是说你的 expectation loss 但是你一方面你会看到，有些学生也学得挺好就再考虑吧。But anyway， 就是人生就是这样嘛，不是你一做什么就是100%，没有这样不像考试你可以拿100%，拿不到，可能我考试拿不到没有希望还是有人拿100%只是说目前还没有人拿过我的100%。数学系里面，希望你们可以拿到。我写出来的东西肯定是希望有人做出来的，不是不要你做出来。但是就是希望是看到哪一个点重要，你们就会注意到那些点。OK， 所以我们有一个机会就是 revision class， 说请把握这个机会，不懂的东西一定要问。OK， 然后我们当下讨论，这个机会很重要revision class， 因为我们不能在 lecture 一直慢慢陪你做的。Sorry 我 train 你们是 train 到有点像那种很独立就是像那种我还好有一个 undergrad 的他来 comment 他说有点像在读 master 课这样他觉得 OK 那个是 M1 啦，比较夸张一点，可能我现在比较收敛一点因为我教你们第3次了不教这个课第3次了，第1次我没有这样收敛了，第1次我要做我就做第2次收一点点，第3次再收一点点看现在收到怎么样？还是你觉得我不够收？Yeah, right 什么？不可以改分就不可以太改分就疯掉了。OK， 我们再看我们再看怎么样？我们再看 ，OK， 看一下怎么样？看一下考试怎么样？看一下assignment怎么样？我们再调整。Right. Okay, so let's start a new chapter now, partial derivative. Maybe we won't go deep, but at least we need to communicate some idea. So what have we done? First, we have done sequence. Okay, so sequence, I told you that it's equivalent to a function. Function from where to where? Function from n to r. Okay, how do we build this sequence here? All the natural number we attach a real number. A1, A2, A3, A4, A5, 6, 4. Second, what we have done series. Okay, so series basically is a sum of sequence. But remember that we have these power series, right? Taylor series, Fourier series, where you input a x, you can output a number. Right, in particular for the Fourier series, right, when it converge, we compute some kind of equation, right? We can find the expression of pi. Remember or not? We can write pi it as a series. 有印象吗? We write pi as a series. Okay, when we evaluate the point. And then in the chapter 10, what do? We do parametric curve. So how to understand parametric curve as a function? We have a function from R to R2. Because I give you a time, you need to tell me two coordinates. Okay, from R to R2. So in this chapter here, what we're gonna learn is a function from R2 to R or R3 to R. So you can see that somewhat we swap the coordinate. Sorry, swap the spaces here, domain and coordinate. Any by one. Okay, so in this chapter we'll learn function like this. So let me write it up. So for example, this one is taking two variable, output one variable, and then we can also go to three-dimensional x, y, z, and then output one variable also. Okay, so you can imagine that we can go Rn, okay, n variable. Okay, if you go higher max. But in this course, we will stop at 3 dimension or 2 dimension. At most 3. Okay. Is it clear? Okay. So we have swapped to this kind of object now. Okay. So go advanced a bit. Right. So let's see. Let's see. Just get rid of this thing first. Use the nice feature we had in our node. Let's look at this. So let's start with the real function of two variables first. So what's the real function of two variables? So 怎样读这个英文字啊？前面又有 real function， 后面又有 two variable， 怎样读啊？ So how do you read it? You should read it as function of two variables first. So meaning this function take in two real variables. So that's why you have 2r. And then real value. Value 什么意思啊 ？Value. What's the value of your phone? 你的电话值多少 ？Okay. So the value here is the image that the app gives you. Okay. So f 去到哪里 is a real value. Okay. So 它是 real number 的 function. Okay or not? So real value means where the codomain live. And then of two real variables here, meaning you take in two real variables here. Okay. So for example, if I change it to complex value, complex value function means what? Let's say if I change it to complex value. So how should you write down your function? Function from R2 to C. Okay, good. Right. So in our class here, we only discuss about this real value of two variables. Let's say start with this first, which assign a ordered pair. Okay, so because this is an element inside R2 to some real number. Okay, 每一个点你给一个 real number. So in this chapter, what you imagine is you start with R2, okay, a plane, and then above this plane, you attach a number, and you can imagine it as a height. 它的高度. Okay, you should do this imagination because we will calculate in this way. So every point you have a height. And with this height, right, you can imagine that you look like mountain, something like that. Okay, depend on how you attach this height. Does it make sense? If the height is negative, okay, 有一点像挖泥土被挖掉. So you have a hole. If you have a hole, you also can use the R2 to R function to describe. Okay. So what am I showing here is actually the graph. Right or not graph? Because this graph here live in R3. So you combine R2 and R together, so it's R3. 对吗? When you do the graph of a real value function of one variable, what do you have? R to R. So R to R, where do you draw the graph? You draw in R2. Okay, this is the function from R to R. But where do you draw the graph? The graph of f live in R2. So you just somehow add these two spaces together. So where is the graph of function from R2 to R? R2 plus R, R3. So live in R3. So R3 is a space with live in R3. So you have three dimensions. Okay, so examples. So examples here. So these are the examples. Do you agree that if I take x squared plus 3y squared, we get a real number or not? If x, y are real? I see a real number, do they? So how about this one? Gxy. Is 2x square root y always a real number or not? No. When is it no? When is it no? Y negative. So meaning what? If I want to make sure this one live in real number, we need to set y to be greater or equal to 0. Okay. So if negative, we drop into complex. Okay, so this is one of the things you need to take note in this class about this function that we use. Right. And then we can define the domain of function. Okay. So meaning the domain of function in this G here, we fix it to be y greater than 0, and then x can be anything. Okay, so here we will denote this as a domain of my function. So let's write this down. So domain for my function. Domain for G. Okay, we can write like this. So it's a domain where the function that makes sense. Okay, makes sense. And then how about range? Range of a function. So range of a function is the set of all values. So how to write these? So for example, the range of R, range of G is what? All the G x y such that x and y live in the limit way. Wait, how should I put this? A bit ugly, huh? So I think should be write it properly using set notation here. So xy in R2 such that this thing hold. So xy should live in DQ. Okay. Okay, does it make sense? Okay, range and the domain here. Right. So next, if we can write fxy, okay, in terms of some function here called z, and what we say here is xy are independent. Okay, 没有关系啊，他们两个。But this equation here will relate z to xy. So z become a dependent variable here. Okay, does it make sense? So in general, your graph will look like this. Okay, this is what I described just now. So you have a domain here, and then if you map using your f, you will get a height. Okay, you will get a height. And then you can try and put all these points together. Then this is just the graph. So this is the graph of graph. How do I write? So instead of drawing lines, you draw surface now. Okay, because in calculus, what you have is you drawing R to R. So actually what you are drawing is this codomain here. What happened to this codomain? For example, what? Fx equals to x squared. So the real line becomes what? The real line becomes this parabola here. Okay, but now your domain is R2. Okay, so meaning your graph should look like a plane. Does it make sense? Okay. Y planes are, you see, how many independent variable here? There are 2. So meaning there should be at least 2 directions on this graph. That's why you span a plane. Span. all the linear algebra word. Okay, it's very useful. Okay, so you span the two direction. But here only R, so only one direction. No? You only have one direction. Okay. So if R3, meaning you need to have three-dimensional things. But all together, what happened if got R3 to R, where the graph looks like? The graph should live in where? 洪婷讲什么 ？R4， 画得出吗 ？R4， 如果你画得出的话，你要打电话跟我讲 ，OK？ 你要打电话跟我讲 ，R4 给我画得出的话 ，OK？Yeah. So far no one draw R4 yet. Okay. So 你如果画得出，记得打电话给我 ，OK？Yeah. 如果我会，我打电话给你 ，OK？ Okay, anyway. Okay, right. Okay, so let's look at this function here. Okay, so first, very easy exercise. Just ask you compute what is f3 2. So basically, you just substitute 3 and 2. Very quickly compute what is this first. So f3 2 is what? It's just square root 3 plus 2 plus 1 over 3 minus 1. Okay, so this is square root 6 over 2. So meaning at this 3, 2, right, what's the height? The height is square root 6 over 2. Okay, this one's easy. But how about domain? Okay, what's the domain such that this number here will live in R? What do you think? What do you need to measure? Just now we mentioned about square root already, right? We don't want it to be negative inside. Meaning what? This domain need to satisfy what condition? So let's write out the set first. So what condition bound x and y? I don't know. Just now we said that everything inside square root need to be positive. So what's the thing inside the square root now? Yeah, so you need to measure that x plus y plus 1 is greater or equal to 0. What else you need to impose? Anything else you need to be careful or not? Now got a division. Can be cannot be 1. So x minus 1 cannot be 1, meaning what? X cannot be 1. X cannot be 1. X can be 0, but cannot be 1. Okay. So if you try to draw out this domain, right? 怎样画这个东西？这个东西怎样画？ Before 画 you should ask yourself, where does D live in? Live in where? R2. Okay. But what's this condition here important? How to draw this condition? Okay, I think this one is easier. X not equal to 1. Meaning what? Every coordinate when x equals to 1, you need to throw away. Throw away? Yeah, throw away. Okay, so we need to throw that away. But how about this condition? How to draw this condition? 怎么画大于等于0啊？如果不会画大于等于0，会不会画等于0？先画等于0先 ，OK？ So 等于0怎么画？ So let's consider x plus y plus 1 equals 0。怎样画这个？这个会画吗？怎样画？ What form makes sense to you? Maybe y equals to minus x minus 1. Okay, so y equals to minus x is what? Going from the second quadrant to fourth quadrant. And then minus 1 just shift down by 1. Okay, so 这条线是有的。大于0小于0呢？在哪里 ？Upper y how to check? 为什么不是 lower? 为什么是 upper? Test good， 对，没有错。Test 就对了，数学就是要 test。什么 test？ 选哪个点来 test？Sorry， 00。Why 为什么我们选00啊？我们 try 一下这一个点，在它上面的。Okay? 如果我们把00丢进来这个 equation， 0加0加1是多少？1，所以1是大于0。Okay, so if you check more points here, you will check that all the x plus y plus 1 should be greater than 0. Okay, and then if you check the other point on the other side, you get x plus y plus 1 is less than 0. Okay or not? So basically, the line that equals 0 break into two part. Okay, break the plane into two parts. On the right hand side, you have greater than 0. On the left hand side, you have less than 0. Okay. Okay, so let's try. Should we try again? Quickly try this one, and then we will finish. Okay, how about this one? Let's not compute the evaluation, but what domain that makes sense to this function here? So there's really one thing you need to be careful, right, in this case. What do you need to be careful? You need to be careful about x. What do you need to be careful about? The norm. What happened now? What happened to norm? What happened to norm? How do you define norm? You define norm from where to where? Sorry? Larger than 0, right? Okay, so you need to make sure that the things inside there is greater than 0. Okay, so strictly greater than 0. Meaning what? Meaning y square is greater than x. How to graph this? 又不会了。会不会 graph 等于的情况 ？y square equals to x. Okay. But y square equal to x is not the normal parabola we consider. Normal, usually we draw y equals to x square, right? So what should it be? It will be how to say rotated. So you rotate your y equals to x squared to here. Okay, C makes sense or not? 小文讲 check make sense? 4号码 Okay, 4号码 So what does it mean by x equals to y squared? Okay, so 4号码 4号码 So x has to be positive, correct or not? So your graph should live on the positive side. Okay, first of all. Second of all, you see that it is symmetric across the x-axis. Hey, wait. Yeah, right. X-axis. Because if you have -1 and 1, they should compute to the same number here. Okay, so you will see that this parabola will grow this way. 可以明白我讲什么吗 ？Okay, 真的是4号码 and then C the symmetry. Okay, so this is an x equals to y squared. So like what we said last time, right? It breaks into a region greater than 0 and less than 0. So which part is greater than 0? Which part is less than 0? How do you determine? 怎么决定 How do you decide whether on the right hand side is greater than 0 or the left hand side? How do you decide? Test again. Good. Test 完了就是要 test. Okay, so test, how to test? You can put a point, let's say 1, 0. So if you put 1, 0 into these two coordinates, what happened? X is 1, y square is 0. So 1 greater than 0, meaning this part is x greater than y squared. Okay, so x greater than y squared. And you also can test that. On the other side, you have y squared greater than x. Okay, so the principle that we say today is test some values. Okay, but in our case, our curve is not tricky, so still okay. You just test value. Okay. In principle, we need to show it in general, but for this algebraic curve should be fine. Okay. If you worry, you can test more number inside here. Test different region. It's okay. And then I think you should see a pattern how to deduce. Okay. If you wonder how to show it rigorously, try a few numbers and then see the pattern. And then I think you can deduce it in general. Okay, why everything on the left satisfies this inequality here, everything on the right satisfies the other inequality. But we don't really care for the moment. Okay, but if you want to show it, you should try more number. Just test value. Okay, yeah. 数学是这样是 start from testing value example, and then 我们就去 abstract.
deduce a general segment. Okay. Yeah. Right. In that case, happy Deepavali. Huh? Country. So see you on Monday after holiday. So if you have problem on your assignment， 有问题 assignment 的话，去我的 office hour 啊，现在开始，好不好？哎，Friday 做什么？啊，有上课，Friday 有上课，希望 Friday。哦，讲错哈，讲错，再讲错，Friday。礼拜82天。Revision 是下个礼拜吗？OK。这个你拿过来，这个